everyone, welcome back to our channel. So far, we have learned a lot about variables. We have learned how to add or multiply two numbers, how to get a substring from a string, and so on. Now, it's time to dig deeper. To start with, let me ask you this. Do you think we can multiply two strings? Does it mean anything? We all know that there is no sense in converting a number to an uppercase or a lowercase form. But if it is a string, then it makes sense to convert a lowercase text to an uppercase or the other way around. This brings us to a key concept in any programming language. It is called data types. This means what type of data a variable can store. Is a variable storing numbers or texts or something else? Here, the vital idea is that the operations such as converting a case, multiplications, divisions, etc. are related to the type of the values the variable holds. For example, if the value is a number, then operations like subtraction, division, greater than check, etc. are allowed. At the same time, certain operations are not allowed for a number too. For example, converting cases is not allowed for numbers. We study data types because many concepts are simplified in that way. For example, once we learn how addition works for an integer variable, we can apply it for all other integer variables. In Python, there are many data types that it supports. We call them built-in types. We will explain only a selected few of them for you. Once we understand the concept, we can learn about other built-in types on our own. The most common built-in data types in Python are integer, float, string, and Bullion. We will explain them now. In addition, there are also a bunch of data types used for holding multiple values under a single variable. We will talk about them in another episode. Now, let's start with integer and float data types. We all know that for any number, it can either be a fraction or a whole number. Float data types are for fraction, whereas integer types are for whole numbers. Python uses int as the shorthand for integers. Now, strings are texts. Remember, we have already explained about it in the previous episode. For string, Python also uses a shorthand str. This leaves us with the last category, Bullion. Let us explain its concept. In computer programming, there are many situations where a possible value for a variable can only be either a true or a false. You may wonder why we are not using text for this. That's because if text data type is used, then it allows all other values as well. So, to apply the restriction of only two possible values, a separate data type is needed. This is what a Boolean data type is. It allows only two values. By the way, one nerdy fun fact. The term Bullion was coined in honor of a 19th century mathematician, George Boole, who introduced a logic system where any statement can either be true or false, but not both. Python uses a shorthand bool for Boolean type 2. Interestingly, we have already seen an example of a Boolean type. Remember, in the earlier episode, we have used the variable is underscore star underscore grocery that stores the result of a string comparison. Since the outcome of this comparison can either be a true or a false, the data type of this variable is Boolean. Along with these common types, there are a bunch of types used for collection of items, like list, tuple, dict, set, etc. We will explore them separately in the future episodes. There is another data type which every programmer must know. While coding, we often need a type that indicates no other types. In Python, it is called none. Similarly, in Java, it's called null. We will close today's episode with some hands-on coding. We will use a Python command called type to print the data types we have just learned. For this, we define 4 variables, val1 to val4, and assign different values to them. Then, we print the type of each variable. Let's see this in Colab. See how Python automatically decides the data types? For example, val2 is of type int, whereas val3 is of type str. Before we close today's episode, remember data types are considered important concepts because it helps us learn behavior of many operators in a generic way. If you ponder a bit, you will also realize that a data type allows a fixed type of behavior. For example, all integers are allowed to be added to other integers but are prohibited to be converted to uppercase. Likewise, a string must follow certain behaviors as well. This is why in advanced programming, we often add more custom data types to specify our preferred behavior. The data types we have just mentioned here are built in Python, and we will learn about the custom types in future. So, stay tuned for that. That's all for today. See you soon. Ciao!